For this final presentation, we are very happy to have Dewinda. Dewinda holds a PhD in computer science from the Institute of Technology Sepuluh November in Indonesia, awarded through the PMDSU scholarship by the Ministry of Research and Higher Education of the Republic of Indonesia. Her doctoral research focused on deep learning techniques for brain MRI analysis, improving model reliability, computational efficiency, and interpretability for clinical diagnostics. She currently serves as head of research at Universal AI, where she co-initiated the research and engineering lab to foster scientific innovation and responsible AI development. Devinda, the floor is yours.
Thank you, Theo. I'll share my screen now. So, can you guys see my screen?
Yeah, all good.
All right, yeah. Well, so first of all, I would like to thank Veronica for inviting me to be one of the speakers for this talk. It is a big honor, and yeah, I'm grateful to share about my research. Yeah, so yeah, previously Tiana and Amelia have talked much about the fairness and also the some cases in medical imaging data sets. And yeah, I think that have given us lots of insights. And from what I will be talking about here, I think it can be like a good complementary insight for all of you. Yeah, so about these findings that I have right now, actually it kind of came from a failed experiment. So in 2020, early 2023, I did a research visit when I was a PhD student at Institut Teknologi 10 November, Indonesia. I did a research visit to Kyunghee University, South Korea. And at the time, our main focus was to investigate multimodal brain MRI analysis. And yeah, so the idea was just to create some kind of novel volumetric multimodal attention-based CNN. And yeah, so my host professor told me to just use the multi-sequence brain MRI data from ADNI datasets, so the T1 and the T2 sequences. And because of this, we have to pair up like the available multi-sequences on the patients. So the reality is that when we try to collect the data set, there are actually limited number of the 3D scans coming from these patients, and especially if we want to take the baseline data set. So my idea was just to first go with the baseline data set, so like the first visit scans from the patients to make it easier, because yeah, if we have to work with longitudinal data, it could be a bit and there are some metadata that we need to take care of. But yeah, because it was limited, so we ended up using the longitudinal data, so the repeated scans from the patients, and we pair it up and make sure that the data set comes from the same patient and from the same visit. And yeah, so we were actually aware of this, that we have to group the data per patient and also according to the visit. But yeah, so we did try to do the training and the experiment, but somehow, if we have to compare the results, both the single sequence and the multi-sequence, it is actually not as high compared to the previous findings. So could we say that it was a failure and dismiss these findings and start over? Yeah, that was like the question. And then, yeah, because from the previous works on Alzheimer's classification, for example, from this paper in biomedical processing, signal processing, I guess. Yeah, so in here they got like completely high accuracy during even the task evaluation. And so as you can see here, the subject level, so the idea is that they did like some research on AD classification based on patch base, so and then the slice base. So the subject and patch base, they are based on 3D CNN. And yeah, so the accuracy was so high. And however, what we achieved that time, if I'm not mistaken, that for the single sequence, it was just around 60% to 70%. Meanwhile, for the multi-sequence, it was like around 70%. Yeah, so it was obviously looking like it was a failure. But then and then I found like some other references on the data leakage, and I was actually at the time curious about it and whether they had leakage or not from the first paper. Yeah, so yeah, apparently from another papers relating to Alzheimer's disease classification. So from Yagi's papers, it talked about the data leakage itself and how it could be we could have like much of accuracy gap when we have the leakage versus the no leakage. Yep. So when we have the leakage, it could reach like 90% accuracy, but when there's no leakage, it's just 68%. So that's actually almost the same with what we ourselves found. And then from another paper for Narasani, so the idea for Narasani's paper, like she wanted to investigate the effect of using only PET versus MRI. And from here, she recommended that it's just actually better to go with PET. But yeah, even so, the accuracy for the testing evaluation, it was not more than 60%. Yeah. So then, we just have like we just continued our research for that. But for this part, so I was curious about the data leakage, and yeah, at that time I like after like around April 2023, after that I didn't have much more experiment to do with my PhD, and so I took the independent initiative to investigate this. And I actually asked my professor, but like they did not find this to be significant to work on together. So yeah, just I took the initiative myself. And the paper for this investigation and findings was presented on Mikai Faimi workshop. Yeah, so let's just move on the background story. Yeah, so what is my finding talking about? Yeah, so but before that, we have to understand about the longitudinal data in brain MRI analysis. So as you know, we have there in medical imaging data set, there can be like repeated scans from the same patients, and they're basically called the longitudinal data. And this is actually important for disease patterns, to see the disease patterns and the progression of the disease for treatment. But somehow it is actually often overlooked when we like compare like many Alzheimer's disease classification paper. They would be just taking the baseline and all. And yeah, and when we have to work with this kind of data, we have to take care of the data handling properly, because it may cause data leakage. And what is data leakage? So I think all of you must have known this, that data leakage can happen when the testing data was leaked to the training data. So yeah, so basically the model have seen that for the test data set, they were already there previously and then seen on the training data set. Yeah. So the idea is that when we work with longitudinal data, we want the subject to be the same patients to be just on the training data and shouldn't be leaked to the testing data. Yeah, so from this investigation, I tried to do this. I have this evaluation scheme. So this is the TOEIC sample. Yeah, so from the data set, I did a augmentation as well. So yeah, in here, imagine if we have like repeated scans from subjects, from the subjects and have the repeated scans, and then each of the scan can also be augmented with several transformation techniques. Yeah, so the idea is that we can have the subject-wise splitting where all the image scans are grouped based on the subjects, just like the left one. And then the idea can also be that there could be the case that in the wrong split that we might do the record-wise split where the data set is grouped based on the time of visit instead of the subjects. Or the other hand, it could be like it's still grouped based on the subject, but it might be grouped more on for default on the augmentation part. Yeah, so this is actually the type of strategy where we split the data first and then we do the or where we do the augmentation first, then do the split after that. So that's actually the wrong split to do if we have cross validations. Yep. So for this experiment, we wanted to do a three-way classification, as previously mentioned. It's the normal MCI and the Alzheimer disease. And the deep learning model that was used is based on the 3D DenseNet by Soloviev. And then the data set that we use is the 3D longitudinal T1 and T2 from ADNI dataset. And yeah, it has to go through the standard processing pipeline. And here's the data set statistics. As mentioned previously, we couldn't collect too many data sets. I think because it was actually, I mean, we had limited time, and also for it was actually tricky because we had to take care of like two MRI sequences. So it's all that we could get. And yeah, and this is apparently the result after some investigations. As you can see that during the record, so we have so we tried it on the T1 and T2, and with the same of subject-wise, record-wise, and let split, it could be seen that during the record wise split, they actually reach the highest training accuracy up to 90% and more. But when it's all actually the same with the late split, but just not as high, even though, but it's still higher compared to the subject-wise split. Yes, and then for the subject-wise split, it's just around 60% like that. And well, yeah, we might be happy when we get like this number, this high accuracy, but well, then after we evaluated it on the holder data, it can be seen that the subject-wise split actually maintained to be the highest accuracy here. And the record-wise split, that was firstly 90% and more during the training set, evaluation set. It reduced a lot to 38% of accuracy. It's the same with the late-wise from 80 to 40%. Yeah, so what does that mean? And yeah, so to understand what it means from the results, we try to do the GradCAM visualization to understand what the model actually learned during the training of the data set. Yeah, and apparently that as we can see that during the subject-wise split, so for the correctly classified, it's still looking fine, but well, as you can see that during the correctly classified for the record-wise split, they in the Alzheimer's especially, they instead of taking care of the brain regions, they also looking at the backgrounds as it also the same with the late split. Yeah, so it is actually from this, I think it's obvious that the model learned through shortcut instead of the actual features that they should look at. Yep. And then, yeah, from this we can get some key insights. So that how the data leakage, how the improper data splitting can lead to data leakage, and it causes the identity confounding within the model, and this can result in a misleadingly optimistic performance. And then from the GradCAM visualization, as I mentioned, there is actually a potential shortcut learning, particularly for the record-wise and let's split strategies. And then, yeah, even so, even if we got like for the subject-wise split, we got like more robust result, but there was actually a high drop of accuracy as well. And from like 60 to like 40%. And yeah, and this kind of underperformance, it indicates that we need to further investigate with potentially larger and more diverse data sets. Yeah, and the limitation from this investigation somehow we didn't like consider some kind of sensitive attributes like age and gender imbalance. I think that's also important to look at that. And yeah, and then regarding to the subject-wise split itself, like I mentioned, it still suffers from underperformance during the hold task, hold evaluation, and it might be due to the underfitting because, like in the Alzheimer's disease, we just had like 50 scans, original scans, but yeah, after the augmentation, it became 300 scans, but still, I think that's not enough. Yep. Yeah, okay, so if you guys wanted to read more for the paper, you can come to this, you can scan this or search for this title. Yeah, and that's my contact if you wanted to discuss more about this. Well, I think that's all from me. Thank you very much for your attention.
Thank you very much for your great talk. Very interesting. For everyone in the audience, if you have any question, you can either type it in the chat or take the mic. And I will start with Veronica that asked a question in the chat, but maybe you want to say it now.
Yeah, I already wrote it in the chat because this is kind of both for Dewinda and Tiarna, in case you also want to respond. So I cannot explain this completely properly because I haven't really worked with explainability so much, but I understood from various research that there are some known problems with GradCAM. If I can try to summarize, is that basically it's not a unique explanation of what might be looked at. So I can share, or maybe Theo, you can share a link to, if you're able, to the paper by Lisa.
Yeah.
So I was wondering, do you know more about these issues, or have you considered, or are you considering using some other methods?
Well, yeah, I know that about the issue with GradCAM, and I can say that the heat map generated by itself is not so smooth. Like it might have some, and it actually depends on like the alpha and beta that you set to the GradCAM. Yep, I know about that. But in here is just for at least just to look at the like what the model learned during the training. So I think somehow that's still helpful. Then like if we don't use any explainability methods at all, in my opinion. What do you think, Diarna?
I would say I agree. I think, especially for my purpose, it was more an illustration of, okay, there are these differences. I agree that it's not the most perfect method, but I think it's better than not using any interpretability method at all. But I do agree that there are better methods out there.
Yeah, thanks. So Theo shared a paper in the chat where essentially they on purpose introduce shortcuts to some chest X-rays, like adding some like cropping, etc., only for one class. And the scans are still classified correctly, so the network actually learns the shortcut. But then the GradCAM and I think several other methods don't actually highlight that area as the one that was learned, even though it's clearly what was learned. So that might be nice to check out. Thanks.
We have, oh, sorry, go ahead. If you want to comment more on that, you can continue if you want. Otherwise, we have a question from Alter in the chat. Do you think simply increasing the number of data will improve the performance with subject-wise split? And the other one is, might the choice of model affect the performance in both accuracy and fairness?
Well, yeah, thank you for the question. Yeah, I think that if we increase the number of data, I think it can increase the performance of the model, and maybe also with the synthetic data set. But I'm not really sure, although I read that paper by Ichoya, I guess, and it helped that to add that kind of synthetic data set. And then for the model, of course, I think the kind of model would affect, but probably not so much. Like, for example, like in the CNN model, like whether it's DenseNet or ResNet, I think the performance, I mean, it might affect, but probably not so much compared to the data itself.
All right. Is there any more questions before we move to the general discussion? So I guess we can thank one last time Dewinda for a great talk, and I will invite all the speakers and chairs to the general discussion.